Hey everybody, thanks for checking this video out today. I just wanted to give you all a quick heads up about the philosophy behind these videos and why we adopt it. While I strive to be as accurate as possible, some of the content in these videos may have deeper explanations or facts or other angles to consider. I know we could go to infinity on some of these topics, but really the reason for these videos is to help beginners or volunteers who have little to no experience in live sound. So yes, while there is a difference between, say, polarity and phase, I'm not necessarily going to go into that unless I feel it's a critical issue in the particular situation I'm talking about. Remember, this is the basics of audio, not a dissertation on minute details involving physics equations. Now, if I'm just plain wrong or misinformed about something, I'm totally fine with you mentioning that in the comments, or you could send me an email at the address on the screen. But remember, be nice. The whole point of this series is to help beginners or people with little to no experience in this field. So, with that being said, I hope you'll find this video helpful. Enjoy. Today we're going to discuss some common terms you'll hear me using throughout this video series. And if you're a volunteer at County Line Church in Auburn, Indiana, you'll likely hear quite a few of these terms during a service. I'm making this video because volunteers, especially at a church, come from all kinds of backgrounds and experience levels. Don't be offended if you're asked to watch this, even though you feel like you already know all this. It's always good to make sure everyone's on the same page. These are in no particular order, so let's get started. Without question, I get asked about what gain means more than anything else. I think it's a confusing term because different people and even manufacturers use the term differently from time to time. So while there are definitely conflicting definitions out there, we're going to say that gain refers to how much a signal is amplified as it passes through a circuit or a device. In the case of live sound, we're likely talking about the preamp in our mixing console or an amplifier of some sort. While I've heard many people say that gain has to do with the loudness of a signal, and it does indeed make a signal louder, I think it's more accurate to say it the way we defined it here. Some manufacturers refer to gain as trim, and while they're pretty similar in function, we'll just say trim offers more precise adjustment than gain does. But in the end, they do more or less the same thing. A common question I get is, hey, what's the difference between gain and the fader on a mixer? This is another example of two things that function similarly, but are not the same thing. Gain, as we've defined it here, refers to a signal's initial amplification, while a fader provides additional volume after that signal has passed through the console. Think of gain as the initial setting that you won't touch once you have it set. Use the faders on a console to make smaller, more fine-tuned changes in volume. Okay, so hopefully I didn't just turn your brain to jelly. This should be the only term that has a little confusion around it. I just want to make sure we're clear on that definition before we go any further because it does make a difference. So when we're dealing with gain, we need to make sure we don't give a channel too much. Otherwise, you'll start hearing clipping or distortion on that channel. Now I know clipping is a form of distortion, but for our purposes, we'll probably use clipping and distortion interchangeably. Basically, clipping will occur when an amplifier attempts to deliver more current or voltage than it's capable of. In most situations in live audio, you don't want this. Take a look at the meter on this console. It's clear into red, which is the console's way of warning you that you're overdriving the preamp. If you see red on your meter, typically you want to back the gain off a bit. Here's why. Listen to this audio channel clipping. I briefly mentioned the word fader earlier. A fader is this device here, which is located on most pro mixing consoles. Some lower end mixers won't have faders, but knobs or encoders. Like I mentioned earlier, a fader is really supposed to be used for fine-tuning your mix, not setting initial volume for your signal. You may hear someone say decibel or dB. This just refers to a measurement of sound pressure. Most people think of it as a way to measure loudness, but that's not really the case. We're measuring sound pressure, which in our situation has more to do with the interaction of the human ear with sound waves. I differentiate because things like EQ can influence the perceived loudness of a signal more than a decibel can in a lot of cases. At County Line, we use a dB meter at the front of house position, which is where the audio engineer would be, to make sure that we're not producing signals loud enough to cause hearing damage or loss. We also use it as a guideline for the loudness of our mix for sure, but again, it's more about sound pressure levels, or SPL. A bus is basically a path to which you can route one or more audio signals to a particular destination. A pretty common bus is a subgroup. So for example, you can route all the drum channels to one group, controlling all those signals with one fader. To keep it simple, just think of a bus as a route for one or more audio signals to go through. And there can and will be multiple buses, especially in live sound. For example, an auxiliary send. When you're dealing with monitor mixes, effects routing, and the like, you're likely going to hear the term aux or aux send, and even just send sometimes. An aux send is a bus. Let's take a look at our graphic here. First, you have your input signal, input meaning your microphone, instrument, or whatever. That signal passes into the console, usually through a preamp, but not always. It's at this stage you can set your gain. From there, the signal can go to multiple destinations via a bus. For instance, you could bus the gained signal of this vocal mic to a floor monitor via aux 1. Note that the signal is still going through the console and out to the main speakers as well. So if you wanted to, you could think of a bus as a copy of the signal you're wanting to send, since that's more or less what's happening in some scenarios. Now, auxes can be pre-fader or post-fader. And on some boards, there are more options, but for our purposes, let's just stick with pre or post fader. Pre-fader means the signal arrives at your destination, think main speakers, floor monitor, etc., as it is before it hits the fader. Basically, all this means is the fader does not affect the aux. If I pull the fader for this vocal mic down, it will not affect the volume of the vocal mic in the floor monitor. That's because I sent the signal to the aux before the fader, or in other words, pre-fader. In most of our situations at County Line, we'll use auxes pre-fader for monitor mixes. That way, if we need to make a fader adjustment for the main speakers, it won't affect the monitor mix. Post-fader means the signal arrives at your destination after the fader. Simply put, it just means that whatever you do to the fader does affect the aux. So if I raise the fader on this vocal mic, it also raises the volume of the mic in the monitor mix. A good example of this type of setup would be our effects sends, which use an aux. If I pull a fader down on a particular vocal mic, I wouldn't want the affected signal to still come through, even though I pulled the fader down. So I send it post-fader. I mentioned a subgroup was a common bus a little earlier, so I better explain what that is. A subgroup is a way to group signals in order to control the collective volume of all of them with one fader. This is particularly handy with drums or vocals where there can be multiple signals. Think kick drum mic, snare drum mic, overheads, etc. And you need to lower or raise the volume of them all. If you have the mix part of it dialed in, but as a group, the drums need to be louder or quieter, it's way easier to just push one fader up or down than try to move every fader and still maintain the mix. And that's exactly what a subgroup does for you. Here's an example of a drum subgroup. Note that the subgroup controls the volume of every channel routed there. So if you were to mute the subgroup, you'd be muting every channel routed there. I've seen a lot of volunteers frustrated because they aren't getting any signal from, say, the drums, and they've checked to make sure each channel is unmuted, but they forgot to check the subgroup. Audio effects are hardware or software devices that manipulate how an audio signal sounds. The two common effects we use here at County Line are reverb and delay. Reverb is an electronically produced echo effect. Think of reverb as what you would hear when you talk in a large cavern or room. Here's an example of reverb. Echo! Not to be confused with reverb, delay is an audio effect which records an input signal and then plays it back after a period of time. The delayed signal may either be played back multiple times or played back into the recording again to create the sound of a repeating, decaying echo. Think of delay as a repeated copy of the original signal. Here's an example of delay. Echo, echo, echo. In just about any mixing situation, you'll be using EQ. EQ is short for equalizer and can simply be defined as frequency-specific volume knobs. For example, if a signal sounds muddy or muffled to me, I can use an EQ to add some high frequencies to the signal like this, or maybe reduce some of the lower frequencies in the signal like this. There are few things that influence a mix more than EQ does. Learning how to use it effectively can be a difference maker. Be sure to watch my tutorial on the basics of EQ. Hertz is a measurement of frequency, so you'll likely be hearing these measurements when dealing with EQ. Here are a few tidbits to help you understand how hertz can be helpful. The generally accepted range of human hearing is 20 hertz to 20 kilohertz, which would be 20,000 hertz. Kilo, or K, equals 1,000, so a kilohertz would be 1,000 hertz. Some of you are wondering when I'm going to make some corny pun or joke about how my head hurts right now, but it's not going to happen, okay? Sometimes you'll hear me refer to a frequency as 2K or something like that. Just keep in mind that the K is for kilo. So 2K would be 2,000 hertz. The lower the hertz, the lower the signal sounds. For instance, a signal at 50 hertz sounds deep and boomy, whereas a signal at 10 kilohertz is very high-pitched. In my experience, compression is the most mysterious and misunderstood tool in mixing. Some folks have heard of it while others haven't, but precious few know what it actually is and how to use it. Here, I'll be defining it, and we'll try to demystify it a little bit. But for more in-depth training, watch my Basics of Compression video. In a basic sense, audio compression is the process of lessening the range between the loudest and quietest parts of an audio signal. And this is done by boosting the quieter signals and attenuating or lowering the louder signals. You may hear the term dynamics used when talking about compression, and this just means the distance between the quietest and loudest signals. So if a singer is very dynamic, it means they're really quiet at some points and really loud at others. A compressor can help level out the signal in these cases. Again, please see my Basics of Compression video for more information. All right, this one's pretty quick and easy. This is a 1/4-inch cable, typically used with instrument outputs like this keyboard or this guitar. So it's not uncommon to hear someone call a 1/4-inch cable an instrument cable. However, just be sure that it is indeed an instrument cable. Speaker cables are also 1/4-inch cables, and so are patch cables. The easiest way to identify which is which is to look at the cable's jacket. Most of the time, it'll say what it is there, like this one here. This is an XLR cable. Some folks like to call them mic cables, and that's fine too. And while there are other cables that use the XLR connectors, such as DMX, most of the time these cables are mic cables. Again, check the jacket of the cable to make sure, like this. Another cable you'll likely see on stage is a Speakon cable. And while there are other manufacturers out there that use this connector, it's most likely you'll see this particular one by Neutrik. This connector is largely used for speaker connections, such as mains or floor monitors. There are lots of other types of connectors and cables out there, but these are the ones you'll see most often. A direct box, or DI, is a device used to convert signals, most commonly an instrument or laptop. Because these devices usually output at levels incompatible with mixers, or they output signal through an incompatible connector, such as a 1/4-inch instrument cable, we need a way to safely and correctly convert those signals to be used in the console. A DI will do that for you, provided you use the right type. For most acoustic guitars, basses, and electric guitars that aren't using an amp, an instrument DI will do the trick for you. As you can see on this DI, there's an input for the instrument cable and an output for the console. A DI does more than just convert connectors. Way too many people, especially church volunteers, think that all you have to do is grab an adapter of some sort that turns this 1/4-inch cable into this XLR cable. And 9 times out of 10, that's wrong, because a DI also changes the signal level as well as the impedance. What's impedance, you ask? Way too geeky for me to cover here. Google it. Laptops, iPods, and other music players also need a specific DI to get the level and impedance matched appropriately. Unsurprisingly, these DIs are usually called PC direct boxes. There are a few kinds available out there, and they're helpful because these actually have 1/8 inch or 3.5 millimeter inputs, RCA inputs, and other helpful inputs that an instrument DI won't have. So definitely use the appropriate DI and avoid just using some adapter or plugging something directly into a mixer. Yes, some mixers do have 1/4 inch inputs on them. Just make sure the device you're plugging into them is what it's intended for. Most pro mixing consoles will have phantom power available. Phantom power, sometimes seen as 48 volts on the console, is typically used for active direct boxes or condenser microphones. Phantom power is literally the console sending 48 volts of electricity down the mic cable to power the direct box or microphone. It's a convenient way to power those devices without having to plug them into a power source, such as a wallboard. So if you have an active DI or condenser mic and you're not getting a signal on the board, check to make sure that phantom power is active on that channel. Some consoles will use different terms for this, but patching is basically the routing of audio signals into and throughout the board. So if you're patching or routing a signal, you're assigning it somewhere. For example, in this Midas Pro 2 console, let's say this vocal mic needs to be routed to input 3 from the stage box. We can patch it by selecting input 3 from the patching window. This procedure looks different on different consoles, so consult your manual or any of the other great videos out there for your particular console. On most digital consoles, you can save a scene or snapshot to your show. And this is super helpful if you have multiple users or situations where you need to reconfigure multiple parameters quickly. Basically, a scene or a snapshot is a saved configuration of your board's settings. Each console does this differently and has different options, so we're just going to do a quick overview of what a scene does. For example, let's say I'm running sound for a musical or a play, and between scene 1 and scene 2 of the play, a different set of characters need to speak. So, in this situation, it might be handy to make a scene on your console for scene 1 of the play, where all the actors speaking are unmuted. And then you can make another scene for scene 2 of the play, where different actors are speaking, and we need to mute the actors from the first scene and unmute the new actors. Now you can absolutely do this manually if you wanted to, but I've done plenty of these musicals where the scene changes are so quick, you'd be lucky to remember who needs muted or unmuted, not to mention remember where those channels are on the board before the scene changed. That's just one example of how scenes can help you. Scenes can store info like fader position, EQ settings, other plugin or effect settings, gain stages, names, and others. So there you have it, a list of common audio terms and what they mean. Hopefully this video was helpful, and if it was, give it a thumbs up. If there are terms I missed or some that you feel need further explanation, please let me know in the comments. Thanks for watching. I'll see you next time.